Hi, in this example I'm going to demonstrate query by example, also known as QBE, and structured query language known as SQL. Now, in order to understand what's going on here, I want to step back and take a look at the way data is stored. And I'm using the HR database, very similar to the one that I gave you, but I changed it slightly. And you'll notice that it uses 4 different tables. So I have taken the combined set of data and broken it down according to common themes of dependent, employee, insurance, and job. And in doing so, I have stored the data in a very efficient way and greatly reduced, if not completely eliminated, data redundancy. So from a storage standpoint, that's a good thing. But as a consequence, I've also fragmented the data into 4 very different themes. And it's likely that when I want to use the data to generate reports, to answer questions, sometimes known as ad hoc queries, I'm going to need to use some of the data in one table and the correlated data in one or more other tables. So how am I going to do that? Well, the answer is I'm going to be having to combine the data in logical ways using some very precise operations that are described in a language called SQL, structured query language. Now, structured query language is a language. It has a very precise syntax. It is very useful, and I would, encourage you, if you're going to be working with data, to learn about SQL in a lot more detail than what I'm going to go into in this course. As a matter of fact, I was just looking at a website the other day. It's one of the major news network websites, and they were listing things that you should put on your resume if you are a professional. And they said, don't elaborate on your skills in Microsoft word processing, because it's kind of assumed nowadays that everybody knows how to use a word processor. But they listed some other skills that you should indicate on your resume, and one of the top 10 skills was SQL. So it's not a terribly difficult language to learn, and after having taken this course and having had this introduction to relational database, it would be very possible for you to pick up a book and teach yourself, or if you're interested in pursuing this further, there's college courses that are offered at Anderson University, for example, that will teach this in far more detail than what you cover in this class. But I want to give you at least enough of an introduction that you know what database queries are, what SQL is, and that you can at least be able to communicate with data professionals in an intelligent way. So in Microsoft Access, which is just one particular relational database management system, we have 2 ways to combine this data in order to generate reports and to be able to answer questions. One way is to do it graphically using QBE. The other way is to use a particular language called SQL. Now, if you know SQL, you're able to do a lot of things that are beyond what can be done in QBE. But QBE is very simple. You'll see just how simple it is. And then, as you acquire skills, you may be able to do more and more things with SQL. QBE is a graphical tool in Microsoft Access that allows you to drag and drop on visual representations of the data, and as you do that, it generates SQL. So we can actually look at the SQL that is generated by QBE. QBE is really just an SQL generator, something that's designed to make it easier for non-technical people to interact with a relational database. So let's get started on this. I have created some questions here, and I'm going to provide the answer to all these questions. I'm going to demonstrate each one of these. So the first question is, in this relational database that I've shown you the relationship diagram of, list all employees, and I want to see their last name, first name, and social security number. Now, you'll notice that I am using a particular keyword here, project. Okay. Project happens to be a term that is applied in relational database. It's an operation, actually, that has to do with determining or filtering the columns that are going to be displayed. So when I say project the last name, first name, and whatever else it was, social security number, I'm saying go to the employee table and filter out the employee ID column, filter out the job ID FK column, but project the employee L name column, project the employee F name column, project the employee S name column, and filter out the other three columns, so that I will get a listing of all my employees, but the only columns that are going to display in that listing, called a result set, is going to be the three columns: last name, first name, and social security number. Okay, so how do I actually do this? Well, I'm going to switch over here to the Access database. Now, this is the actual Access database. Currently, it's filtering for queries, and I deleted all the queries that previously existed so that we could start fresh. I'll show you, let's see what happened here. You've selected tables and views as a way to group objects. Access needs to update information. All right, I made some changes to the tables. I didn't anticipate this. I'm just going to say okay. Apparently, it wasn't such a big deal. That should not have happened, except that I went in and changed some columns in the employee table. So it hadn't completely updated the database structure, and that's what it was squawking about. Okay, so I have these four tables, and if I look at them by going to the database tools page and clicking on relationship, you'll see that's the same diagram that I showed in the Word document that I was accessing a moment ago. And what I want to do this time is focus on this table, on the employee table. I'm going to ignore the depend table, insure table, and job table. Just ask a question of the database management system with regards to this employee table. And what I want to see is a complete listing of all my employees, but I only want to see their last name, first name, and social security number. So how can I do that? Well, in order to do that, I need to create a query. So I'm going to go to the Create page, and I have a query ribbon. I have two ways to do this. I'm going to ignore the Query Wizard feature and design this myself. So I'm going to click on the Design button, and I immediately get a dialog box where I can choose which table or tables that I want to use. And in this case, I want to use only the employee table. And then I'm going to close up the dialog box, and what I see then is the employee table, the columns that exist in the employee table, much like what I saw in the relationship diagram. And I see a grid down here at the bottom. This is query by example. This is the QBE grid. And if I want to see a complete listing of all my employees, last name, first name, and social security number, then what I do is, from the relationship diagram part of the form, drag down, and drop onto the grid. Excuse me. And if there's a check in this box, then it will display in the result set, in the output, that column data. And so I'm going to have the last name followed by the the first name followed by the last name followed by the social security number. So I just drag and drop. And then to actually see the result set, I can run the query, and there's a listing of all my employees. If I were to go to the employee table, I would see that there's 1, 2, 3, 4, 5, 6, 7 employees. Okay, but if I opened up the employee table, I'd see other columns. I only see the columns that I instructed the database management system to display. And so here's an example of a result set, and this answers my question. Again, what would be known as an ad hoc query. This has provided me a result set for my question as to who my employees are and what their social security numbers are. And I see the output in this grid-like structure. Now, we're very shortly going to look at how we can transform this output into something that's very aesthetically pleasing, put it in a professional report-like format, and we'll see how we can even then generate web pages that have that, professional, aesthetically pleasing, professional look to it. But right now, I'm seeing kind of the raw output in what's called a result set. Okay, so there you have query number 1. Now, if I anticipate asking this question periodically, maybe at the end of every month, I want to know who are my employees, who are my employees, then rather than having to execute that query over and over again, what I can do is save the query. And I'll just put down QRY all employees. So I can name it anything I want to, and I precede it with QRY because when I sometimes generate a list of database objects, it will show me in the list tables and reports and queries all in the same list. And if I precede my query with the key characters QRY, then immediately it's a heads up to me that that's a set of instructions. So I'm storing the instructions to generate this. Now, what is it actually storing? If I go over to View and choose SQL, QBE has generated this code. And that may not be real easy for you to see, so I'm going to do a Control-C, and I'm going to go to the search box here and type in Notepad and execute a Control-V and enlarge that font a little bit. Okay, and maybe that makes it a little bit easier for you. But it begins the instruction that was generated, and this is the instruction that is processed by the database management system. This is an instruction that is in a standard query language, SQL, a language that's used with most, if not all, commercial database management systems, to include SQL Server, MySQL, Oracle, and there are some others. But this is the language that professionals really need to learn. This was generated by QBE, and the select statement is the keyword that's used to tell which columns to project. So I'm telling it, project the employee L name column from the employee table. The employee dot employee L name is in the syntax table dot column name. So all these are coming from the employee table, and what follows the dot then is the specific column. And so if I write the SQL myself, which is something you ought to strive to do, then I have to follow this very precise syntax and name things exactly as they're named in the design of the database table. And then second line reads from, and it's the from clause that you tell the source from which you want to generate the output. In this case, I'm saying from a single table, the employee table. Now, having saved that query, okay, I don't know what I did. I messed with it, and it thinks it needs to be saved again, so I'll just, oops, forget that. It doesn't want to. I'm gonna not save, because that's saved in Microsoft Access. What it was doing was, oh, wait a minute. I'm sorry. I was using Notepad. I was trying to save that representation in Notepad. Okay, never mind. I'm confusing myself here. I have previously saved that query, which means these instructions are saved within the database management system. And I'm going to close up the query, and I'm going to go back and filter for tables or something like that. So if let me try that again, tables and related views. Okay, so if it's 6 months from now, and I happen to be working with database tables, which incidentally there are 7 records. I just opened that table that I queried from a moment ago. There are 7 records in here, as I indicated. If I'm 6 months from now, if I open this table doing something and say, I'd really like to see that query, I'd really like to have those results that I had created previously, I can go to the object bar. I can filter for queries. Okay, if I can find queries and related views, let's see, navigate to category, object type, maybe. Okay, so here's queries. If I want to execute that query, I need only to change to the query's object type, double click, and it'll execute those stored instructions again. And if it's 6 or 7 months from now and my employees have changed, then my result set will be different, because it's always going to apply that instruction to whatever data is in that table. And if the data in the table changes, then the result set would change as well. Okay, so hopefully that makes sense, and that's an example of how I would then create a query to do this. Next query, I want to do something a little bit different. Okay, so I want to project the last name, first name, and social security number. So I want the same columns displayed, but I want to add an additional column. I want to also add their current salary, so I'm going to add one more column to that. And then I'm going to perform a second operation in that instruction. Besides projection, I'm going to perform a selection operation. And what that's going to do is allow me to determine which employees of a particular salary range I want to see. So let's go to the, I'll actually execute 2 instructions here. So let's go back to the database, and I'm going to go to the create page and choose query design, and I'm going to use the employee table and only the employee table again. I'll stretch this out so we can see it. And I want to see the last name again. I want to see the first name again. I want to see the social security number again. And I want to see the current salary. Now, I'm going to just simply project those fields. Okay. And I see that there are, let's see, 1, 2, 3, 4 records with salaries greater than 50,000. Okay. Now, for a small set of data like this, I mean, I could probably keep track of all this data on index cards. Wouldn't even need a computer or a relational database. But if I had hundreds of thousands of employees, I might be interested in knowing who are my employees that have salaries, greater than 50,000. Maybe times are hard, and I need to start looking at trimming back my expenses. And one way of doing that would be to maybe fire certain employees. It's a pretty brutal way of looking at things, but nevertheless, you get the idea that I might want to see just the employees that have salaries greater than 50,000. In order to identify among these rows of data only the rows that have salary values greater than 50,000, I need to perform what's called a selection operation. So I'm going to close up this table. I'll say yes, I moved something around. I'm not sure. Okay, okay, sorry. That's not what was happening. Okay, so this is my result set. Let me go back here to design view. This is what I really want to do. Okay, and now what I'm going to do is I'm going to take this field employee current salary and I'm going to drop it down on the grid again, but this time I'm going to uncheck the display because I don't want to see that column of data twice. But I'm going to go to the criteria row and I'm going to put in the criteria greater than 50,000 and then execute the query. And when I do, it shows me that there are 4 employees that have salaries greater than 50,000, and these are the ones that are displayed. All the employees that have salaries less than 50,000 are ignored from the result set. Okay, so I have performed a not only a projection operation to get 1, 2, 3, 4 columns displayed, but I have performed a selection operation that controls what rows are output, and it has resulted in only 4 of the 7 rows being displayed. So let's take a look at the SQL. And here's the SQL. Same as before, the select statement. Let me highlight this and do a Control-C and open Notepad again so you can see this more clearly. Okay, so as before, I have the select statement controlling which columns are output, the from statement controlling which table I use, and the where clause controlling which rows among that table are included in the result set. So this is really manipulating kind of the horizontal dimension of the tabular structure of the table, and this is manipulating the vertical dimension of the table. So hopefully that makes sense. All right, I'm going to close this up, not save anything, and go back here to design view, and I'll save this instruction, and I'll call this QRY EMP sal greater than 50,000. And I now have a second query. And again, 6 months from now or whenever I want to see that same set of instructions run, I don't have to type them in a second time. I can just double click and there they will be. And if the table data changes, the result set will not be the same. Okay, so let's go back to the Word document and take a look at query number 3. List all employees, last name, first name, Social Security, current salary. So I'm projecting the same things I did in query 2 and apply the selection criteria. What did I do? I did the same thing twice there. Am I doing the same thing? List all employees, first name, last name, current salary, and apply selection criteria. Okay, so when I type this in, I may have just copied and pasted, so I think I'm just going to eliminate this altogether. And let's take a look at query number 4. List all employees, project their last name, first name, social security number, job title. Okay, so this is going to be different here. And current salary. So as I look at the way the data is stored, I can get the last name, first name, social security number, current salary. I can get all that from the employee table, but their job type, which would be their job description, is in the insure table. So let's go over and take a look at something here, because this is going to bring into play the idea of a foreign key and a primary key. So as I look at the relational database tables, and I look at the employee table, I see that the employee table has a job ID foreign key, and I see that Kuntz and FUD are both of a type of employee that is denoted as primary key 1 in the job table. I'm storing the corresponding job records primary key as a foreign key value here. So if Kuntz and FUD store a foreign key value of 1, and I close up the employee table and now open up the job table, job 1 is faculty, okay? And job 2 is administrator. So if I now go back to the employee table, I'd find that Yosemite Sam is a administrator, and Homer Simpson and the Three Stooges there are of different types. So they're 4 and 5, and so that would mean that Homer Simpson is in housekeeping, and the Three Stooges are in IT. Okay, so the point being this, that some of the data that I need for my results set, most of the data that I need for my results set is going to come from the employee table, last name, first name, social security number, and current salary, but job title is going to have to come from the job table. I'm going to have to correlate data between these two tables, and I want to match things up properly so that the Three Stooges don't show up as faculty and Kuntz doesn't show up in IT, if you get the idea. Okay, so how am I going to do that? In the Access database, I'll go to the query design view, and this time include 2 tables, the employee table, and I'll control click on job and add both of them, and you'll see that it shows me a more complete relationship diagram up here at the top, so I can see that relationship. And now I can begin to drag down, same as before, so last name and first name and social security number, and then if I want to see the job title, bring it down, and what was the other thing, the current salary, bring it down here, and then execute this, and what it's going to do is generate an SQL command that is going to perform a variety of operations. It's going to perform projection in order to list the 1, 2, 3, 4, 5 different columns. It will list all employees when I execute it the first time, and then I'll change it and only list certain employees. But the first time I run this, I'll have it display all the employees and their corresponding job title. Now, if you remember the data from when I showed you that in the tables a moment ago, this should look familiar. So we find that Kuntz is faculty, we find that Fudd is faculty, Yosemite Sam is an administrator, and the Three Stooges are IT, and Homer Simpson's housekeeping. It's what we saw previously. So what has it done? It's taken this data, this data, this data, and this data, and correlated it with data in the job table in order to produce this complete set of data that combines data from two tables. So again, the data was stored originally in the database design. We did this purposely. We stored the data in separate tables in order to avoid data redundancy, but the consequence of that was that it fragmented the data, and our means of putting Humpty Dumpty back together again here is to execute SQL with an inner join. And let's go back and take a look at that query in SQL view, and you'll see that what I have, let me copy this over so it's more readable and put it in Notepad, which I keep closing up. Okay, sorry. So open up Notepad, and so typically what I do when I do this is I write this on multiple lines, and I don't put that semicolon at the end. That's not important. But my first line is telling me the columns that are going to be projected. Select statement tells the columns that are going to be projected. The from statement tells me the source of the data, except this time, rather than just specifying a single table, I specify two tables, employee and job table. Okay. Let me find that. This is written this in a kind of a peculiar way. Okay, from job, inner join, employee. Okay, there we are. Now let me break this down on a separate line. If I were typing this in, I'd put it on 3 different lines just to make it more readable. So select statement telling me which columns to include in the result set. The second line is telling me really 2 things. One, the tables that are involved, and secondly, the operation that's required in order to correlate the data in those tables. And what I'm creating is what's called an inner join, and that's the way that data is typically correlated. Now, I will show you one other type of join, but by just dragging and dropping on the QBE grid, it's going to default to an inner join, which will show me all the records that can be correlated between the 2 tables. If there are records in one table or the other that cannot be matched, that do not have primary key and foreign key values that can be matched, then they're excluded from the result set. So when I perform an inner join, I don't necessarily get every single row of data from both tables. I only get the rows of data where the primary key in one table matches the foreign key in another table. All right, so that is an inner join. And I will close this up again without saving. Okay, so let's take a look at what's next. We've seen the inner join then, and now I'll show you a different kind of join, and I'm going to show you how to create an instruction using the SQL editor. Okay, So this one says, list all employees who have salaries that exceed the maximum salary for the job table. All right, now I just poked some data in these tables. I didn't really pay much attention. So let's go back. I'm going to save this query. And this will be QRY, EMP, and job title. I'll just say in job. Okay, so I got another query saved, and I'm going to close this. That set of instructions is saved. And now what I want to do is take a look at the tables, particularly trying to figure out how to do this just by table. I do that, I think. Nope. Okay, never mind. I want to see the employee data and the job data. Okay, so let me start with job data. Okay, so there are faculty. Faculty have an upper limit of $100,000, and administrators have an upper limit of $125,000. Now let me go to the employee table real quick. My phone is ringing in the background, so I'll ignore it. Sorry about the interruption. I meant to shut that off. All right, so Kuntz has a salary that's within range. Elmer Fudd. What was Elmer Fudd? Elmer Fudd is a faculty member, so his job ID is 1, and he's a faculty member that makes $120,000. Okay, so he exceeds the faculty maximum. Now, again, remember the scenario I described before. We have this business operation, and we're trying to cut costs, and we're looking to eliminate, some expenses. So maybe what I'm interested in knowing is who are my employees that have salaries that exceed the recommended maximum. The recommended maximum would be the max column figure in the job table. Get it right. In the job table. Okay. So job max salary is the recommended maximum, and we know that Kuntz is within those limits, and that Elmer Fudd is not. So how could I identify people whose actual job salary, again, employee table, actual job salary exceeds the maximum? Before I show you how to write an instruction to identify the employees that have a current salary that exceeds the recommended salary, I want to show you a change that I made just a moment ago to the job table. So I had to stop the recording and slip this in real quick in order to be able to illustrate something here in the SQL instruction. But if I go to the job table, notice that I have added a new record, data analyst, okay? And that's record number 6. And if I go to the employee table, there are no employees that have been hired for that position. Okay, so this would be a case where maybe the business creates a new job position and hasn't filled it yet. Let's see, 1, 2, 4, 5. Notice there's no job 3 either in that list. So going back to the job table, and I have a primary key value of 3 that corresponds with grounds, and in the employee table there was not a foreign key value of 3 So apparently we don't have any groundskeepers, and having just added this record in the job table, we don't have any data analysts yet either. So I've got 2 jobs for which there are no employees. Okay, so understanding that, now let me go into SQL, and this time I'm going to use the SQL editor without using query by example. So when I get this dialog box, I'm just going to close it and switch right over to SQL view. And I think I still have this on the clipboard. So let's see. Yeah. So I have a SQL command on the clipboard, and I've also got a copy of this in Notepad where it'll be a little bit easier to read. So let's take a look at what all I have here. I'm going to be projecting many columns, okay? The employee last name, first name, social security, those all come from the employee table. Job title, that's going to come from the job table, okay? So that has to be correlated with the correct records in the employee table. And then the employee's current salary, which comes from the employee table, and then also the job max salary. So the last 2 columns are going to show me on every row the employee's actual salary and what the maximum salary should be given that employee's job title. So that's, those are the columns that I'm going to project. Now I'm going to project these from the by combining data in the employee table and the job table, but I'm going to be using a different kind of operation. Okay, so I don't know how that became lowercase. I put it uppercase. Okay, so I'm going to be using a different kind of join than I illustrated before. Now I told you before that the most common way to correlate records between tables is to use an inner join, and what that'll do is it will pair up all the records that it can where the primary key of the parent table matches the foreign key of the child table. In this instance, it's going to do the same thing, but it will give me a complete listing of one of the tables. So I've got 3 different operators that I can use here: right, left, and I think both, maybe. But in this case, I'm using the directional operator right, and what this is saying is correlate all the records that you can between the employee table and the job table based upon the primary key of the parent table having a value that matches the foreign key of the child table, but also list all of the records on the right that pertain to the right table. So with respect to the operator, right, outer join, job table is on the right, employee table is on the left. So this is going to do what the inner join did, but rather than ignoring unmatched records, it will go ahead and show me the unmatched records from the job table, or in other words, the table that's mentioned on the right of the operator. So let's see how this thing works. If I go back to Microsoft Access and execute the command, what you're going to see is that Kuntz is still correlated with faculty. FUD is still correlated with faculty. Yosemite Sam's still an administrator. So it's pairing the correct records. The Three Stooges down here are still, shown to be having a job title of IT. But rather than ignoring the record here and the record here, where there is no matching data in the employee table, it still shows me all of the job data. So I'm seeing all the data from the job table and all the corresponding data from the employee table. And that's what an outer join does for me. It lets me see the pairing of the data between the two tables and then unpaired records. If I use the left operator or right operator, I see all the records from one table or the other. Now, you don't have to get too overly concerned about that, but this is a different kind of join, and it's going to eventually lead us to this issue of identifying who the employee is who has a salary that exceeds the maximum recommended. So let's take a look at it, just inspect this. The current employee salary for row 1 is within range. The current employee salary for row 2 is not within range, and that person is a person I want to be able to identify as someone who I might get rid of. Third record is certainly within range. Fourth record within range. Fifth record barely within range. And the whatever that is, sixth record and seventh record are all within range. So there's only one record in this entire table, in the employee table, who has a actual salary, current salary, that exceeds the maximum salary. And again, the maximum salary is stored in the job table, the current salary is stored in the employee table, so I have to do some sort of correlation. And what I'm going to do to generate that final listing is to go into SQL view and modify. In fact, I think what I'll do is change it here where you can see it more clearly. Okay, I'm going to change this so that I will select a record from this mix where clause is used for selection operation, where employee underscore current underscore salary, I think is the way it is supposed to be written, is greater than, let's check the spelling of this. Yeah. Job underscore max salary. And if I spelled everything correctly, and hopefully I have, I'm going to highlight all this, do a Control C. So it's going to give me that same output, except what it's going to do is eliminate all rows that don't meet this final criteria, what's in the where clause, and the only row that meets that criteria, where the current salary is greater than the job max salary, will be Elmer Fudd, as we've seen just from inspecting the data. So let me go ahead and change this and then execute the command, and there we have Elmer Fudd being the only employee whose current salary exceeds the maximum salary. And I have now found someone to fire so that I can save myself about $121,000 a year. Okay, so let's go back one last time to the lecture outline, and we have seen an example here of how I would use the SQL editor if I know the language. and how I would be able to type in a useful command that is otherwise not, that's misspelled. How about outer? Okay, so if I only know how to use QBE, it's going to be nearly impossible to execute a query like this, a more complex query. So, QBE has its place. It's easy to use. As you learn SQL, it's really convenient to be able to describe things in the QBE grid and look at the SQL that it generates and learn from it. But at some point, as you need to execute more and more complex queries, the QBE grid becomes, pretty much useless, and the only way you're really going to be able to do it is to learn the SQL language. And I've just given you a quick primer. There's a lot more that I could show you. I teach a database programming class in the computer science curriculum, and we spend the better part of a semester learning SQL and then a superset of SQL called TSQL. So there's a lot more to know about this, but my intention here was just to give you a quick primer. And again, hopefully if you ever find yourself in a position where you need to work with data from an Access database, you'll feel comfortable enough to be able to use QBE. And if you find yourself needing to know more, you'll have at least some idea of what you need to prepare yourself for.